Hey, I'm over here at the Advanced Technology Zone at the Intel Developers Forum here in Moscone Center, San Francisco, to check out all the new processor toys coming out in 2008. Let's see what they got going on. Right, I'm here with Amanda from Intel, and we're actually at one of the little demonstrations they have at the booth up here. Can you explain what exactly it is you're showing off here?
Absolutely. What we have here is a demonstration showing Lost Planet Extreme Condition on two different computers. They're identical in every way except for the processor that's in them. In this computer over here, we have a Core 2 Extreme that's currently on the market that's dual core. And in this one, we have a quad core Extreme that will be available next year. And what you can see on the monitors in front of me is the frame rate that you get between the two different ones. And on the dual core Extreme, you get much lower frame rates because it's not able to take advantage of the 4 cores, where in this case you have 4 cores on a 45 nanometer processor. And sometimes you're getting frame rates that are up to 3 times greater than in the dual core Extreme.
Cool. I'm here with Ramesh over at the Intel booth. Ramesh, what do you do?
So I'm the program manager for this media PC evaluation tool that we've developed. It's called Intel DHCAT, and we are doing the 3rd revision of it. Okay, so it evaluates the top 5 media PC usages that consumers care about, namely like play HD video, record TV, and being able to create your personal video libraries, audio libraries, and photo libraries.
The media PC has different factors that determine whether or not it's a good machine versus a desktop, for work, for gaming kind of PC. So you have to come up with a different metric in order to kind of measure the quality of the experience that traditional ones like gaming benchmarks or office benchmarks wouldn't be adequately able to cover.
Yeah, precisely. Like as part of the demo, we are testing 2 scenarios. The first scenario has play HD video in DivX, create HD video in DivX, and encode audio from raw format into WMA. So the 3 usages that are currently being tested in this particular scenario here. As you can see here, what you have on the left is the reference file, that's the input signal. On the right, you have the degraded file or the recorded file, and it's actually doing a frame-by-frame comparison. And as you can see on this system, the MOS stands for mean opinion score. It's very close to 5, or basically excellent experience.
Hey, I'm over here with Patrick at the Integrated Graphics booth over here at the IDF. Now, Patrick, one of the things that people often kind of skewer Intel's graphics solution is that they're kind of slow, especially when games are a factor.
I can show you right here that I'm getting a playable gaming experience. I'm up in the 30, almost to 40 frames a second on the top 25 game, Call of Duty 2. Over here on Fear, I'm getting an average of 27 frames a second. 55% of the frames are well over 25 frames a second. That's a good gaming experience.
Now, what did you do with this generation that you didn't have in the previous generation that allows you to kind of pull stuff off that most people thought was impossible, a year ago?
Well, one thing that we've done is we've added hardware vertex processing, or vertex processing on the Intel Integrated Graphics product. Previously, it had all been done on the CPU. And for some cases, it does work better on our Intel Integrated Graphics. In other cases, it's best on the CPU.
Now, obviously, you're not going head-to-head on the high-end graphics market, but you are kind of aiming toward the middle range or the low end of the GPU market?
I would say that we're mainstream. We're gaming, or we're graphics for the mainstream market. It's good enough graphics for everyone, but I think you are seeing a shift into Intel taking graphics seriously. This is opening the door, so to speak, and future generations will only get better.
Cool. Thank you very much. Hey, I'm here at the IDF over at Moscone Center with Dave Salvatore, the Intel Performance Evangelist. What exactly do you do?
Well, I do a number of things. One of the main things I do is not only sort of talk to folks about the great performance of Intel products, but I also work in the area of what's called methodology design, which is how do you test? What's the right way to test a certain platform for a certain type of application?
All right, so what do we have right behind us, Dave?
What we have right behind us is a 3 gigahertz Wolfdale architecture, which is to say it's the Pentium generation architecture, dual core. There's a 3 gigahertz machine using integrated graphics. And the thing to notice is there's a watt meter right behind me here. And when the system's here at idle, it's only pulling about as much power from the wall as a typical light bulb, about 60 watts. This is part of a program that we call Energy Efficient Performance here at Intel. And what that has to do with is there's been a lot of talk about energy efficiency, a lot of concern about energy efficiency and environmental impact of information technology. And it's one of these things that we've kind of been advocating for a while, that we believe when you're talking about energy efficiency, it's extremely important to not leave performance out of the conversation, because performance actually has a lot to do with energy efficiency. The faster you get your work done, the faster you can get back to idle, the faster your system can go to sleep. So in some sense, you use less energy by having more performance.
All right, now, Dave, right behind us we have two laptops, and one is running a Penryn, the other one's running the old Marome processor. So what is this going to demonstrate for us?
Well, what we want to show here is that the new instruction set, the SSE4 instruction set, is actually going to deliver some great benefit for people who do digital content creation, what we call DCC. We're going to show you an application here called Virtual Dub, which is a video encoding application. Things like video encoders are going to be some of the first kinds of apps that really see benefit from SSE4, but you'll see other apps. Once the SSE4 parts are hitting the market, you will see other apps beginning to benefit from it as well. We have a little sort of shootout we can do here to show you the benefit of SSE4. So why don't we take a look at that? Okay, we're running an application here called Virtual Dub, which is going to do a video encode for us. These are two systems from Dell, which are identical except for the CPU. One of them has the new Penryn CPU. One is running our current generation Marome. They're both great CPUs, but you're going to see that one of them, thanks to SSE4, is going dramatically faster. Okay, system on the left has already completed. System on the right is still chugging away, just about done, but you can see the system on the left is quite a bit faster.
All right, Dave, what do we have right between you and I?
Right between you and I, we basically have a system called with our new X38 platform, which has a single Yorkfield, which is a quad-core CPU clocked at 3 gigahertz. Next to it, we have our Monster, which is a Skull Trail, which has two quad-core CPUs clocked at 3.4 gigahertz, running an application called Cinebench 10, which is actually a 3D renderer. And this is to sort of demonstrate the benefit you can get from going from 2 cores to 4 cores. Digital content creation apps in particular can spawn what are called X number of threads. And what we mean by that is however many cores are present, it will kick off that many threads to make the workload go that much faster. And Cinebench does a pretty good job of dramatically demonstrating that benefit.
Now, do you need any kind of OS modification or tweaks in order to benefit, or should you be able to slap on any existing OS and have that benefit out of the gate?
If the OS is multiprocessor aware, it will pretty much be transparent to the OS. It will basically, manage the number of cores it's given, and the kernel scheduler will take advantage of the cores present in the system.
All right, this last machine we have looks to be like a calendar.
Well, it's much more than a calendar, though. It's called GPU Viewer, and what it allows you to do is basically take your photo collection and store it in what is kind of a calendar interface, but what that does is it organizes the photos by when you took them. But the really cool thing is the number of what we call levels of detail. You can basically start from what you can almost think of as orbiting the Earth, and then as you drill down on the photos, you can get down to the very high-resolution photos and see then details within the photos. So it's actually this very slick app that lets you sort of zoom way out, look at all your photos at a kind of a very high level, and then zoom in on them, and then look at specific photos.
Cool. Thanks, Dave.
Thank you. Me.